So good afternoon all. My name is Sarada Prasad. So I mostly work on networking and security aspect like blockchain, cloud computing, and authentication. So currently I'm looking mostly into post-quantum cryptography and quantum cryptography. However, I sometimes also look into network from the signal perspective, that is the jamming, one of such work. Here, our objective was to see how MMWave, that is one of the important aspect in both 6G, 5G and 6G network, how we can understand the signal that is being gathered, or statistics that we can gather in the MMWave, and try to use this in order to configure or for self configuration in order to enhance the performance of the system. The motivation is like in the first half, as we saw, that a tremendous amount of effort is going towards ensuring this augmented reality setup, or similarly, we are interested into virtual reality as well as remote surgery. So we think that if there is a requirement of such fiber-like connectivity, which currently we can provide at the last mile of communication, so that the RAN network gets all the most of the connectivity to our internet. So if we can replace this fiber-like connectivity to wireless medium by using a millimeter wave, then how it's going to be and what we can do over there in order to ensure that we provide better performances. So this is the sole objective. Like we have our the internet over here, and currently we are being connected with fiber optics to our home. So you might have seen like fiber to the home kind of infrastructure. But however, if we are trying to develop wireless medium or wireless system in which we want to provide data rate of gigabyte by using millimeter wave. So how we can use it, how we can design the systems is the main goal of this fixed wire broadband access. But at the same time, we can envision of scenarios in which we can mount these millimeter wave devices on drones so that it can be helpful in scenarios such as disaster relief scenario, or in for military purpose as well. So a tremendous amount of effort has been going on international bodies, and especially FCC has opened up some bandwidth over here. So from 27.5 to 40 gigahertz, and similarly from 64 to 71, as well as some 81 to 85. So there is this effort to ensure that we get higher bandwidth by venturing into higher spectrum domains. And here our objective is to ensure that when we can design such systems, if they can self-configure in order, in other words, if they orient their direction, if that is going to help them improve the performances, so how they can do it. So currently there are some data sets available in which we can learn and design systems for self-orientation. However, some of those were all generated by simulations. So we thought of using the existing millimeter wave transmitters and receivers. I'll show you about it. How we can gather the data about it, how we can run some machine learning algorithm in order to learn how we can self-configure. So this is the device that we have got it. This is RWM6050. This is the millimeter wave transceiver. So from Fujikura. So they have two components, namely the PCP and STA. So they can communicate between among themselves. So this is a Linux-based system where we have host PD and also WPA. So they communicate, and using these two Linux daemons, so we try to gather some of the statistics. So our objective was like we will try to put them in different location, try to see if they are in line of sight, or if they try to move, change their orientation, how it would impact in their and using in this particular tool, or this particular transceiver, we have we can gather several statistics informations of link layer performances, such as average disease power, SNR, and packet error ratio. So all these things we try to see from the perspective of the distance and orientation. So our main objective was to select the features which are most relevant to us. So for that, we try to use both principal component analysis, in which we gather we take the information as some data without even relying much on what it is. So by using this principal component analysis, we can see that by considering 10 different features, so we can try to get good our variance somewhat reduces. So we think that 10 number of components are good. Similarly, we also try to extract the features by using MRMR, that is maximum relevance and minimum redundancy. And so by using this, we try to gather to 10 different data or features. And so we use these features in order to classify them. So we try to use it first using this online classifier as Kitsune, and this is based on our autoencoder. So and it was an hierarchical autoencoder. So it worked quite well when we are working on with our intrusion detection systems. So we thought of using it in order to classify it, and this gives quite good performance when we talk in terms of the distance. So we saw that the relationship between the prediction and the transmission distance was somewhat linear, and we expected that, and we could identify using our Kitsune. And the same thing also goes like when we wanted to do multi-class classifications. For distance, everything seemed good. Our confusion matrix showed good performance. However, when we went to the angle, we saw that sometimes the system was clearly identifying or classifying them. For example, when it was 20 feet apart, we saw that it could completely identify what is the angle, and distance was 50. It also did perform well. However, there was some kind of variance which we could observe from 30 and 30 and 40 feet apart. We thought that that could be the issue with the data that we have. So we even further did multi-label classification in order to see how better it can identify. But unfortunately, the online classification did not perform that well for the orientation or the angle. So we tried to apply for the offline classification. We realized that LSTM has some it helps us to understand the temporal behavior of the data. So we wanted to exploit it. And for that, we used two different architectures, namely the multiple class and multi-head classification. And again, everything quite well for our distance prediction. And as we expected the offline classifier to do perform a bit better. And also the same thing we can observe for angle prediction. And this went well for multi-head model. As you can see that multi-head model, normally when we try to gather the extract the features, PCA, we got better performance. However, MRMR did not give that better performance in the multi-head. In multi-class, we found that MRMR gave higher or better performances than others. So what we have understood, like yes, there is a higher possibility that we can identify both the distance and orientation. And next, how can we use this information in order to take appropriate decision is the next task. So hopefully this particular data set and the information that we have could be useful for cell phone configurations for better performances. With this, I would like to thank you all for your patience and the opportunity.
Long live India and France friendship.